Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on important questions from electronic devices of class 12. Basic focus will be on rectifiers. Most of these questions are from board exam papers. What is rectification? Draw a circuit diagram of half-wave rectifier and also input and output waveform. What is rectifier? A device which converts AC into DC. So rectification is the process of conversion of AC into DC. What is AC? Alternating current, and DC is direct current. Alternating current in which direction and magnitude both change with time. DC current in which direction and magnitude remain fixed. Now, we have to draw a circuit diagram of half-wave rectifier. What is half-wave rectifier? Rectifier which converts half of AC into DC. One cycle of AC is converted into DC. And we have to draw the input and output waveforms. This is the circuit diagram. We take transformer, step-down transformer. This is the insulation of transformer. Input of this transformer is connected to AC mains. And this is primary. This is secondary. S is connected to diode. And N region is connected to resistance. And resistance whose second end is connected to S dash. Secondary. Now, what happens? We have to draw input and output waveform. For that, we have to understand the working. You are not supposed to write working here in this question because it is not asked, but I am telling you how it works. When positive cycle appears across this diode, then what happens? This upper end of secondary S dash becomes positive and lower end becomes negative. So positive is connected to P. And negative is connected to this end. So forward biasing is favored. So this diode conducts when forward biased. So output is there because it conducts and current flows through this resistance. And output is obtained across this resistance. That means when positive cycle is there, we get output. So we get waveform. But when we apply negative cycle on upper end, of secondary, it becomes negative and lower end becomes positive. Now this B is given negative. So forward biasing is not favored. This will not conduct. This diode will not conduct. So no current will flow through this circuit and no output. That means what happens? This diode conducts when forward biased. So when positive cycle is given to diode, only then it conducts and we get output waveform. But when we give negative waveform to this diode, what happens? It does not conduct. So no output is obtained. Again, when positive cycle appears, again we get output across this RL. So half of AC is being converted into DC because only positive cycle is being converted into DC. Across negative cycle, we are not getting any output. That is why it is known as half-wave rectifier. So these are input and output waveforms. In case of half-wave rectifier. Now next question, device X here converts the input voltage waveform into output voltage waveform as shown in figure. Name the device and draw its circuit diagram. Now here check. Across positive we are getting some positive waveform. Across this negative we are getting positive waveform. That means whole of AC is being converted into DC. This is DC, fluctuating DC, in which magnitude is fluctuating but direction is same. So these fluctuations or ripples can be removed by using suitable filters to obtain pure DC. So what happens here? Both cycle of AC are being converted into DC. That is why it is known as full wave rectifier. So this device is full wave rectifier. Now we have to draw its circuit diagram. Here two diodes will be used. This is the transformer. One diode D1, second diode D2. Now what happens? To upper end of secondary, D1 is connected, to lower end, D2 is connected, and both N are connected to RL. A end of RL and B end is connected to center of secondary of transformer. This is insulation. Now what happens? In positive cycle, when positive cycle is given to diode D1, this cycle is given. Then upper end, S2 becomes positive, S2 dash becomes negative. So this P is provided positive and this N is provided negative. So this is forward biased. This diode D1 is forward bias. So it will conduct and current will flow through this circuit from A to B. That means A end is positive and B end is negative. So output will appear across this RL. So that means across positive cycle, we are getting positive cycle in output. Now what happens when negative cycle is applied? When we apply negative cycle to this diode, upper end becomes negative, lower end becomes positive. So what happens? This P is given negative. So it is, this diode D1 is reverse biased. Now D2 is given, this P is given positive. So it is, D2 is forward biased. So D2 will conduct. Now D1 will not conduct. D2 will conduct. When D2 will conduct, again current will flow in this direction from A to B, making end A positive and B negative. In previous case also A was positive and B was negative. Here also A is positive and B is negative. That means in output, direction of current remains same. That is why we say that AC is converted into DC. Here both cycle of AC across it, we get DC. We get waveform in output. So a full cycle of AC is converted into DC. That is why it is known as full wave rectifier. Now in this question, you were supposed to name the device. It is full wave rectifier. And to draw the circuit diagram, you have to draw this circuit diagram. If it is asked, explain working only, then you have to write the working steps. Thanks for watching this video. Like, share, subscribe my channel.